today I want to talk about Vanilla Fusion, why it's the future of DeFi, and why it's so useful for the developers and for the community, for everyone who is trying to use it, actually. Let's start from small recap. What is 1inch? Maybe somebody don't know what is it. Basically, right now, it's one of the leading DeFi projects. We do have almost 3 million users. We do have a multi-billion volumes of liquidity going through us. We do have 70% volume of aggregation, like 70% aggregation market share. And 1inch was built on one of the hackathons like this a couple of years ago at New York. Basically, yeah, like there you go, it was a birthday of 1inch, almost 4 years we are on the market right now. For these years, we built multiple protocols. Right now, it's not only aggregation protocol, it's a list of protocols. It's also limit order protocol that, and Anton recently just had a talk about limit order protocol like almost 2 hours ago on the main stage. We do also have a 1inch Fusion protocol. We do have a 1inch wallet. It's a non-custodial wallet for multiple platforms like Android and Apple. And we do have a 1inch Pro as a product for institutionals. So I just want to make a small recap about one of the main two protocols. The first one is aggregation protocol. It's our OG protocol, the first one. Basically, what it helps to do, it helps you to basically to build a road from any token to any other token, ERC20 token, I mean, and execute all of these roads in one atomic transaction. And what is cool about that, that when you do something like this, this road actually is quite smart and quite well optimized. We split the swap from source token to the destination token into several small parts. And we optimize percentage of each share that goes through each part. And it can be quite advanced. We can have more than 100 parts during the swap. So basically, that's how we started. And it's quite easy to actually start to use aggregation protocol. There are two parties here. The first one is 1inch router. And almost anyone can just make a transaction on 1inch router. It's completely open sourced. You can take a look how it works. Basically, what you need just to make a transaction, like just to build a transaction and pay for it and execute it on the Ethereum. And we do have an API for that. And basically, what you can do, you can use 1inch API to get firstly the quote, basically to understand what will be the return amount of any token. And if you are OK with that, you basically just go and swap it. But basically, just build call data firstly, and later execute it on the transaction. It's quite simple, and it's only on-chain. But there are some issues that are happening right now. One of it is actually MIF attacks. Like, if your user will just try to execute a very large swap during, like, on the public network, it can be easily sandwiched and lose a lot of money because of the slippage. It requires users to actually set slippage quite lower. If you set slippage very low, your transaction can be reverted because the market conditions can change. So it's also a problem how to balance your transaction, how to set up it so you will not be sandwiched or somehow attacked by somebody who is searching for move. And at the same time, you need to execute it without any painful experience, without any reverse. So you don't want to wait too much in this case. So yeah, you can basically use 1inch swap even right now. It's quite easy. There is a QR code with the link about on the documentation. So we do have a quite advanced developer portal that is evolving every day. So you can take a look. You're always welcome to take a look. So we started to research on how we can make it even more advanced, how you can trade without any slippage, with slippage protection. And so 1inch limit protocol appeared. Basically, it helps you to set up a limit order, quite the same logic as on any SEX. So you don't have any issues with the slippage. Also, it's completely off-chain for the user, so you don't pay for the gas at all. The only thing that you need to specify the price, the rate for your return amount. After that, you send it to the 1inch app, like to the 1inch database, basically, or like it can be P2P as well. You don't need only to send it to the 1inch database if you want to do this. And after that, any party in DeFi can execute this order if the price is actually quite OK for this party. there is no any price guarantee that it will be executed. But if the price is quite okay, for example, if you make an order for right now for 1,700 Ethereum, for example, per day, if somebody will execute it because it's quite profitable for this party. So there are a lot of features that you can build on top of limit order, but the most important is just it's well optimized, it's quite efficient, and we have about 80% of volumes going through our limit order right now. Yeah, so let's talk a bit how it works. Like basically there are two parties. It's a market maker, it's a user who basically just create and sign the order and share this order through all the network. And there is another party, it's market taker, that basically needs to search across all users' orders. And if the market taker basically finds something that is suitable, that is quite profitable, they just need to execute that. That's it. Basically, there is a quite good market on that. And this is like a small scheme how it works. We do have a small separation here that's going for where it's going off-chain and where it's on-chain. So basically, only part that is on-chain, it's execution of limit order. All other parts are actually off-chain. So we have right now we have two great protocols. One is for market sell. Basically, you can use aggregation protocol if you just need to sell something very fast with any slippage, for example. You don't care. You just need to sell something. It works quite well. It gets one of the best roads on the market. And we do have quite advanced trading protocol for professionals who want to specify the rate, who are okay to wait a bit. This is limit order protocol. But what if we want to do want to have some balance between it? What if we want to actually have something like market sell, but we are okay to wait a bit? Like in an aggregation protocol, you basically made only one transaction, one on-chain transaction. What if you want to sell on the market, but you can wait and you don't need to wait for, if you don't want to make only one on-chain transaction, you're okay to have multiple of them, for example. In this case, diffusion actually burned. We decided to make an auction. Basically, it's kind of a fusion between aggregation protocol and limit order protocol. Basically, you're trying to make a market sell. At the same time, you have specific hard-coded rates going down during a specific amount of time. So on each moment of this time, the price is quite okay. And any party who is trying to actually take your order and execute it, they have enough time to calculate the profits and to find any resources, any liquidity to execute this order. At the same time, you don't need to pay for gas. And at the same time, it also basically works on the market because there is a competition between multiple parties who are trying to fill your order. So basically, that's what is actually is fusion. It works quite the same as almost our legacy protocol. It's aggregation protocol. It's pretty the same user experience, but we have additional features on top of it for the user. Sometimes it can be taken a bit wrong, so I just want to go through all of them and just explain how it actually works and what are the trade-offs in this case. So there are three main features. It's firstly gasless execution. So basically, you don't need to pay for gas in Ethereum for a native currency. For example, if you use Ethereum network, you have a MIF protection by default. So basically, nobody can front run you or do something with the user. And also, we don't have issues with liquidity because it's almost limitless, because basically any party can aggregate liquidity from any source, and they have enough time for that. So let's talk about gasless execution a bit. It's quite simple. It's almost the same as experience with limit order, because user just needs to sign specific data structure. It's completely off-chain. It goes to the storage database, and basically that's it. There is one problem that even if you don't do anything on chain, it doesn't mean that it's completely free. There is no any commission or fee in terms of swap, because somebody still need to fill the transaction. Somebody still need to pay on chain, and that basically means that the price of the trade is some fees are included in the rate. So the rate goes a bit maybe less better than it can be executed in case of aggregation protocol in some cases. But it's actually not that transparent. It depends only on the market taker party, and it can go much more better than an aggregation protocol. It can go worse. It depends case by case. that because we have like a competition market, and we can't predict what will be the fee for the user in the end of all. Usually it can be a bit less expensive than paying for gas directly, because the main reason why it is like that, Fusion is quite optimized. You don't need to make too much on-chain transactions, and also parties who actually fill Fusion orders, they can batch all of them. So they make only one on-chain transaction and fill multiple Fusion orders at the same time. So it's a bit more optimized because we have a bundle inside. So basically, yeah, all orders actually executed on the blockchain side by market takers. Actually, we call them resolvers in terms of Fusion. Let's see the scheme about actually resolvers, this party. After user sends something to the limit order storage, to the storage with all these Fusion orders, there is a resolvers who actually searching for all orders that are happening on chain off chain. And what they need to do, basically, they see how the price going down, and when they see the target price is quite profitable for them, they trying to execute this trade on chain, paying commission and gas fee for that. At that moment, basically, there is a small issue. It's because it's happening on chain. There is a possibility that somebody can actually front run the resolvers. So, but of course, the protection from the users are completely protected in this case, because there is a MIF protection on the user side, because there is no any on-chain activity on their side, basically. But that doesn't mean there is no completely MIF protection on all steps of the protocol. So resolvers needs to pay some risks to understand how to get out of these attacks. And so there is a small issue here, but it's always quite okay, because resolvers can only lose money, that only lose their profits. They can't lose your order or your assets. They only lose the money from executing from the profits of the trade, if somebody can try to attack them, and for example, for sandwich attack. So basically, another opportunity here is that resolvers are always professional traders. They have quite a lot of experience executing orders, and in this case, it's quite okay, because if users need to think about MIF protection, it's quite painful. If it's only resolvers who are professionals, it's quite okay for them. Basically, they can handle that, and they do this. And a small point about limitless liquidity. So what does it basically mean? The main reason why it works so well is because we don't have one atomic transaction. The problem with aggregation protocol is that Pathfinder or any algo that we do have, it needs to aggregate all liquidity and make transaction on chain immediately. We don't have enough time to wait until some confirmations from other exchanges. We can't unlock something inside one transaction, so it's quite painful. We don't have enough opportunities sometimes to collect some liquidity from other chains, especially in case of some shitcoins, for example. Let's imagine you do swap on one chain and you want to trade on another chain the same shitcoin, but there is no any liquidity there. If you will try to do something completely on chain, it will be quite impossible to aggregate liquidity from other chain if you don't know about this order. If you are doing something the same on Fusion, you basically have resolvers, basically they have enough time to search across multiple chains to find this liquidity, trying to bridge this liquidity to this chain, and just get a better rate for the user. So in the end of all, the user gets more than on the legacy mode. So this is like basic scheme how it works. It's quite almost the same as limit orders, but there is a small difference. It's resolvers, and this mechanism of the mechanics, how we allow, how the DAO allows some resolvers to execute the orders. Right now, if you want to execute the orders from one each network, you need to be on the top 10 of the resolvers. To make it possible, you firstly need to register a resolver, and after that, you need to ask your users, the stakers of one each token, to delegate some tokens to your party, basically, to the resolver. So top 10 of them can execute all these Fusion orders, and so it's quite simple and works almost the same as limit order. There is a storage database. It's going through, the database shares all Fusion orders to the resolvers. Any party can execute, any resolver party can execute any order at any moment using the one each limit order protocol, and also on each router to ensure that it will be completely secure, and in the end of all, user will get enough tokens that was promised on the conditions of the transaction that was signed. So let's talk a bit how we can work with Vantage Fusion, and maybe make a small example. I will show some small examples about that. There are actually multiple options how you can work as a software developer with Vantage Fusion. The first one is quite simple. You can integrate Vantage Fusion to your API, to your wallet, to your D app. Basically, any app that requires to swap any token to any other token is quite a good use case to use Vantage Fusion. Also, it's completely free, and there is no any commission fee. Basically, you just need to integrate it, and that's it. We do have partnerships, and you can also get enterprise API if you're a large business. If you do need some additional quotes, additional limits, it's also possible right now. And another option is basically that you can try to be a resolver, a Vantage resolver, and also execute orders on behalf of the users and actually get some profits in this case. All of that is quite open and quite transparent and quite easy to build. So we do have a Vantage documentation. And the most easiest way how you can work with Vantage Fusion right now, it's a Vantage Fusion SDK. It's written on the TypeScript. Right now, there is also a Rust version. And you do also can work with API or with the smart contract directly. But if you want to take a look and just to try to make some fun, SDK is one of the best options. And we do have several examples how to work with that that are directly in the documentation and in the GitHub repository of that. So let's make a run and go through several options how we can run a transaction using Vantage Fusion. Let me just open my IDE and just show how it works. So let's take a look. It's basically just basic projects that I made on the TypeScript using Node. That's what I want to do here. I just want to find a way how we can get a quote. Basically, what I want to understand how to make a quote from DAI to wrap BNB, for example, to understand what will be the expected amount, what will be the return rate. If you want to integrate something, I want first to start to get a quotes on that. So it's almost one line of code. This is an example how you can actually implement it using Vantage Fusion. It's almost I don't know, 16 lines, 10 lines of code. All you need is just specify a network. In this case, let it be Binance, for example. It can be any other chain that we do support. We do support almost 10 chains right now for the Fusion. And after that, you just need to specify, by default, only several parameters. It's a from token address, to token address, and amount in terms of from token address. And after that, it's just a basic API call. So just let's run it. Let's just take a look. Oh, sorry, I think I don't have internet right now. Basically, I already executed it almost a couple of minutes ago. And there is example, what it will return. It's basically a file, like a structure with recommendations and with return rate that you got. You can see that we do have a from token amount that I already specified. And there are multiple presets how auction can be executed. You can specify any preset, and we just do recommend to use the default preset, the recommended one. So the transaction will go through with the most efficient and fastest way. But you can also specify different presets for the auction. And also add additional parameters, such as permit or additional fee if you want to specify a fee, for example, for your app. So the experience is quite the same when you understand that the quote is quite okay for you. In this case, this is actually the 2 token amount. This is like the rate that you get in wrapped BNB tokens, swapping 1,000 DAI. So it's like 3 to 3 something. It will be like this actually in BNB case. It's a bit outdated because I just ran it 10 minutes ago, but it's close to the reality. If you're okay with this price, the second step that you need to do after you actually get a quote, you need to execute transaction. Basically, you need to create a Fusion order on the behalf of the user. To make it that possible, you just can take a look on the example on documentation or on in this code. It's almost the same. You just need to specify from token address to token address the same amount that you already specified. Also, wallet address, who is basically making this transaction, making this order. To get a wallet address and actually to sign this transaction, you need to actually have a private key. So you can use one of the abstractions that we do have an SDK for the private key. It's quite easy to use it. You just need to install Web3 and implement several functions. You can use any library for that. Not only Web3, but Address.js, for example, or any Web3 library that just signs transaction, basically. And you also do need to have a node for executing the transaction. So basically, that's it. If you will execute this transaction, you also need to have a proof before you're making this transaction. You don't need to forget that everyone who is making an order, it needs to make a proof with the amount of tokens that you want to execute on the 1-inch router address. Otherwise, it will be not executed because it's impossible to withdraw any tokens from your address. And yeah, basically that's it. After you will execute the transaction, you will get another ID. And after basically you will get another ID, you basically need to understand how to track this order, how to understand when it will be executed. So there are another 2 functions to make it possible. You can get orders of any party using 2 functions. The first one is get all active orders. It just shows the whole list of orders that are on the 1-inch limit order database. And another one is actually allows you to specify the maker, basically the user who made the transaction. So you can take a look on all users limit orders and take a look at all details that are happening there. Yeah, that's the quick overview how to work with 1-inch SDK. I just want to repeat, there is also a way how you can delegate some tokens to any 1-inch resolver. This is how UI looks like. There is top 10 resolvers, and any user can delegate only to one resolver some 1-inch tokens, and top 10 of them have opportunity to execute all of these orders that are created. Even your resolver can participate here. The entry barrier is quite low right now, so just do if you want and you like the business of resolvers or market taking or market making business. If you are quite advanced here or like it, you can participate and just get some market share and earn on it. Yeah, I just want to mention that if you're a 1-inch resolver, we don't have a specific scheme that every resolver forced to pay something to the users. Basically, you cannot pay nothing. But in this case, if you will pay nothing, you will be quite unpopular, and you will get out of top 10, and nobody will delegate for you. So resolvers, they have incentives to pay for the users some rewards from the profits of these transactions. Otherwise, they will be not in top 10 right now. So yeah, basically that's it. If you will have any questions about resolvers and Fusion integration to the 1-inch Fusion and resolvers, I will be downstairs. I will be always happy to help. And if you have some questions right now, I will be also happy to answer them. Thank you.
Cool, thanks. Yeah, I was interested. So the barrier, though, to becoming a resolver, right, is that it seems like from what I was looking at, like you need to put up a couple $100,000 in 1-inch tokens, right? So no.
Basically, the first point of what you need to do when you become a resolver, you just need to create a pod. It's actually a function inside Solidity. Yeah. You just need to be registered as a resolver. It requires some 1-inch tokens, but the entry point is like 50, 100 1-inch tokens. So it's quite low. But if you want to be in the top 10, yes, in this case, you need to attract attention from the users, from the delegations. It must be not only fans of the resolver. It can be fans of any party, any user. Yeah.
Okay, because I thought that I read that it said that only the top 10 get access to the Fusion order book.
Yes, yes.
But if I can't get into the top 10 without having a significant amount of users initially delegate to me.
Yes,
right?
You need to attract some users. In this case, we do have grants to help resolvers to actually get into the top 10. And basically, the entry barrier right now is not hundreds of thousands of 1-inch tokens. It's a bit lower. So you can just take a look on the front-end side, for example. Yeah. So like the top 10 is like actually quite lower than like thousands of 1-inch tokens. Let's take a look. Sorry, I don't have internet right now. So.
No, it's okay. And then for delivery, right? Because I've used the one in the Fusion router, right? And I've seen sort of the paths that they sort of take to resolve the things, though.
Yeah.
If I'm resolving through a centralized exchange, right, then it's just a matter of delivering the amount of tokens for the specified rate, as opposed to actually sourcing it back on chain and then sort of taking the users, right? So if somebody's trying to swap the 10 million huge order of USDC to BTC, and I have the BTC or to wrap BTC in my wallet, right? Then it's just a matter of sort of, I can just do a delivery and I can, on my own backend, right?
Yeah.
Okay.
Yeah, basically the main case here is that resolvers are quite open. They don't have any restrictions to execute the order. They just need to be compliant. In our case, we are obligatory to be compliant. But resolver can have any logic how they execute the order. So for example, you can use your own funds. You can use Aave, borrowing liquidity from the users of the Aave, for example, with the collateral. There can be any logic. The only thing that you need from the resolver party, there is one function called fill fusion order. And you just need to specify the order and the amount, and that's it. It can even be not atomic. You can fill the same order several times if you have some opportunity to fill it.
Right. Okay. And you said that for the resolvers it's written in Rust, or there's a Rust implementation for?
There is a library in Rust. You can execute. You can use it. Actually, it's quite open. You just need the only thing that you need from us basically right now is just access to the data of the orders. It's going through. There are multiple options like WebSocket, and you can execute everything on your own language. So there is no any requirements for resolver to use specific language or specific stack or framework. We do have two libraries that are quite simpler to work. It's a good start. It's a Rust library. This is a community version, and we do have SDK and TypeScript as a entry barrier to have a low entry barrier. Yeah.
Got it. Thank you. Very interesting.
Can I ask a question?
Yeah.
First of all, thanks, Nikita, for a great presentation. And I also have a question regarding the Rust SDK. You mentioned that it's community-owned, so it's not in the official documents of the 1.8.
There is a link there. Or you can take a look in the GitHub, for example. There is a list of all libraries, and one of them is Rust implementation. Yeah, it's community version, so you take your own risks if you're working with that. But basically, what I can say that almost working with Vantage Fusion SDK, if you especially are a resolver, it's quite simple. It's extremely simple. And basically, if you're going seriously on that, you almost don't need any SDK. It's just like 3 functions implemented. You can take a look how they are implemented and basically implemented on their own if you just need to specify some advanced parameters, for example. So SDK is more first just to take a look and to play. Basically, the entry barrier is just smart contracts and one API handle to get the order. That's it.
Okay, thanks. Yeah, and one more question regarding the how can we test the resolver? So is there any testnet, or we can do it only in prod?
Right now, it's only possible in production, but if you're building your own resolver, basically what you can do, you can make your own environment like in Truffle. There are some options. We actually have implementation of basic resolver contract. So right now we are working to have a small ecosystem that you can run on locally and basically run a resolver and all the parties on local host with your own local fork of the network. It's it's a work in progress right now here. If you are taking serious that point, you just need to write it on your own, like write a resolver and run it on your local network, like Ganache or something like that.
Okay, thank you.
You're welcome.
Anybody else?
Thank you.